I don't know how you wear shorts, man. My legs in sunlight. So it's like you got this dark body over here and you got like your legs on there. I'd rather spare everyone. Yeah.
Okay, I posted this announcement, which was just to say from here on out so there'll be no late homework accepted. So it makes it easier to do it this way. Now, inevitably, there are things out of your control where you just absolutely can't get it to me on time, and so for that, I give you a few at the end of the semester will drop. Okay? So save those for things out of your control. Don't think, oh, it's okay if I don't have my homework in this week because it'll just be one of the ones I drop. Because then something's going to happen where you plan to turn it in and you couldn't, right? And if that happens too often, then your grade starts going down. Okay, so save up your cushion dropped homeworks for things out of your control. That's what they're there for. Okay, and then for the heading, so in terms of getting it folded right, so we'll start to deduct. You just need a little motivation. It's very easy to do correctly, but some people need motivation, so this is what it is. There'll be a deduction in your score if you don't fold, put the heading on correctly, and get the spiral fringe off. It helps me immensely if all students do this correctly, and it's easy for you to do. So I just appreciate your cooperation. Here's the heading for today. And so remember to put your recitation time and not 10:30. Okay, any questions about that? So when you're ready, pass them up.
I was trying to write on the back of this page, right on the back of this page.
Okay, so why is it there? Okay, so what's going to start happening now is we're going to realize quickly that everything we've done so far, we need desperately to continue on. All these ideas are going to keep building and building. I haven't selected what we've done up to this point very carefully because it's all necessary. And so as it gets harder, you can't forget things. You can't just toss things out of your memory banks. And so these ideas that we've covered so far are critically important as they continue to build on one another. So when you're working your homework, you've really got to discipline yourself to get out of the habit of just trying to get the answer so I can get the homework done and turn it in and move on to something else. It's really when you're practicing the ideas. The points of the homework questions are practicing your understanding of things so that you retain it, and when we start building on it, you can draw on it. Okay? That's really what your goal has to be when you're doing this. So I don't want that. So everything we've done so far is really we're kind of crescendoing to this very important idea of accumulation. Okay, accumulation. So that's what we're going to start talking about today. And so this should look familiar. This is the marginal tax rate function over here. And this is the tax due function. And so what this is just in general showing is this thinking about taxes is more than just kind of a static thing where at the end of the year, so the way we think about taxes is, the end of the year, we see what our taxable income is, and then the tax table or our tax accountant spits out a number and says, this is how much tax you owe. Okay? But we're trying to think of it in a different way in terms of accumulation. That your taxable income is growing consistently throughout the year. At the beginning of the year, you haven't made anything yet. Halfway through the year, you've made close to half your taxable income. And then at the end of the year, you've made all your taxable income. And as it grows, the tax is growing along with it. So we want to really think of this as a dynamic situation. So we have a bunch of questions here to just really make sure we understand what's going on. So the first question is, where in this animation should you look? So this is for a person named Sarah. Where in this animation should you look to see her taxable income growing? Where here should you look to see her taxable income growing? Where in this animation?
On the x-axis?
Which one, the left or the right?
Either one.
He says on the x-axis, either one. Agree? And what specifically about the x-axis are you looking at that represents her taxable income growing? Somebody else?
We're looking at the change in x.
Okay, we're looking at the change in x. Yeah, kind of like the change in x from the beginning of the year. So what is representing that? What is showing that taxable income growing? Like, what's the visual here? That's you know. The slope of the line is showing the taxable income. So what's showing that or just talking about the taxable income? What about the x-axis is showing the taxable income?
Is it the black line that's being graphed?
Yeah, you see this bar? It's like one of our horizontal bars. So the bar, the end of the bar is showing in any given moment what the taxable income is. Okay, so that it's like one of our horizontal bars mapping out the value of the quantity. In this case, that quantity is taxable income. Okay, where in this animation should you look to see her marginal tax rate for the current value of her taxable income? Okay, oh, that's fine. Okay, no problem. So where in this should you look to see her marginal tax rate for the current value of her taxable income? Yeah, Joe.
The y-axis on the left.
He wants the y-axis on the left graph. Agree with that? Yeah, that's what's showing. So as the taxable income increases, the y value is showing the tax rate. Okay, where in this animation should you look to see the amount that Sarah owes for the current value of her taxable income? The amount that she owes for her current value of taxable income. Adrian.
The blue line.
The blue line. So where would I look to see? So how does the blue line tell me what the tax that she owes is?
The corresponding y value to the x value.
She wants the y value on this right-hand graph. What do you think? Yeah? Okay. That's right. So the y value on this graph is showing the rate for her taxable income, and the y value on this graph is showing how much tax she owes. Okay, what does the current value of her taxable income mean if that isn't continually changing? So we said the black bar is showing how the taxable income is continually increasing. So what does the current value of her taxable income mean? Nathan?
Current value is what it's being taxed at that rate.
Okay, so just really actually focusing on the taxable income. What does it mean, the current value of her taxable income? Is it Jenica?
Her value over the year. That's
Okay, value over the year. Connor?
Isn't it just however large the x value is the value?
Okay, and so what we'd have to do is, really to be able to do this, is we'd we kind of had to pause it, right? It's kind of like it's continually increasing. To talk about the current value of the taxable income means we have to kind of pause the situation. Imagine just time freezing for a moment. And then what would the current value be? Like, what current value am I showing here?
41 to 42,000?
Yeah, about 41 to 42,000. All right, so we think of it continually increasing, but if we pause life at a moment, then we'd have a current value. Okay, so what does a point, say that point right there, what does a point on this graph represent? So we could just, that one, or we could make another one, say down here. What does it represent, a point on that right-hand graph? Somebody knew? Jeff? Okay, the amount of tax owed?
At that current income level.
At that current income level. It represents two pieces of information, right? So that was correct. It's the amount of tax owed, but at a particular income level. A point on a graph is really representing two pieces of associated information, right? Okay, what does a point on the left-hand graph represent? Yeah. Right. So again, two pieces of information. The rate of tax at a given taxable income. So right now we're at what, like about 41, 42,000? And the tax rate is at that taxable income? 25%. Okay? So that point represents those two pieces of information taken together. Why does the graph in marginal tax rate jump discontinually? Start it back up again. Why does the graph in marginal tax rate jump discontinuously? Isabel?
And it's because for each specific range or bracket of taxable income, there is a specific tax rate.
Okay.
Just that range and amount.
Okay. So how much tax do I pay on the $8,375 that I make? How much tax do I pay on that? That $1, that dollar. So I've made that $1, the $8,375. How much tax do I pay on it? John? 10%. And then the next penny that I make, what percent of tax do I pay on that? 15%. So, and then the next dollar after that, how much do I pay? 15%. So right there at the 83, that break point, 83.75, the tax rate jumps up. I was paying 10% all along for every dollar, but then suddenly for the next any amount of money after that, I suddenly start paying 15%. Why does the graph of tax due versus tax income change slope abruptly? Back here. Somebody in the back. Somebody new. Yeah. Will.
Because it changes the tax rate abruptly.
Okay.
So once it gets to a certain income, it doesn't just gradually rise up. It just jumps to the next tax rate. So that's where we see the abrupt changes.
Yeah. So how we've talked about, what does slope represent? What does slope represent? Bailey. What does slope represent?
It represents like the comparison between the two values, the x and the y.
Okay. It represents how tax due compares to taxable income. And what is that? What do we call that?
Rate of change.
That's the rate of change, right? The slope is the rate of change. How much tax due changes for a given change in taxable income. So if the slope is rate of change, then why is there a abrupt change in slope there and an abrupt change in slope there. Yeah, Adrian.
Because the constant rate of change changes at those points?
Yeah, so if the slope was a constant rate of change, and we saw that that's what the marginal tax rate is, the rate of change. If the rate of change jumps, then our slope's going to jump. The slope is going to abruptly jump. Sorry, it's not really jumping, it's abruptly changing, right? The slope abruptly changes. Okay, so in what way does her tax due accumulate? What way does her tax due accumulate? So this is the big idea that we're going to talk about today. Somebody new. Yeah.
Say she has $20,000 taxable income.
Okay.
So that the tax due she will pay will be the $20,000 subtracted by the $8,375 of the first tax bracket.
Okay.
Which will be at what is that? No, it's not 10%. It's 15%. That's at 15%, and that's the amount that exceeds that first $375, and then you add that to that first $375, which is at a tax rate of 10%, to get the total tax rate of both of those together.
Okay, so this is what I heard you say. So there's going to be an amount that we make are taxed at the first rate, and then there's a total amount we tax at the second rate. And so it accumulates by adding those two together and then adding the third amount. Is that
yes.
kind of like three amounts?
Yeah.
Okay. All right. So that's the right idea. So let's think about like snow. How does snow accumulate? So when you see it starts to snow, and you walk outside your door, and then you close your eyes and you open your eyes back up again, and there's a foot of snow, right? And then you close your eyes and open them back up again, and there's 2 feet of snow. And then you close your eyes and open it, and then there's 3 feet of snow. Is this how snow accumulates? No. Okay. So that's a little bit kind of like what you said was not incorrect. What you said was correct. But in terms of if we really want to analyze how something accumulates, it doesn't accumulate in these big chunks like dust in your house, right? If you live in a well-ventilated house and you dust, and then or wherever you live, the dorm or the apartment or whatever. And then so you dust, and then you come back a day later. Is there an inch of dust? No. But in a year, there might be a lot of dust, right? If you don't dust, how does that dust accumulate? Yeah.
Gradually over time.
Yeah, gradually over time, in bits, in little bits. So in a couple days, there may be a little bit of dust. A couple days later, then there's a little bit more. So how do things accumulate? They accumulate bit by bit by bit. They don't accumulate in big chunks, right? They don't accumulate in big chunks. So even though the tax rate is jumping abruptly, how does this show that the tax is accumulating? Let's put it up again. How does that show that it's accumulating bit by bit? How can we represent that? How is it showing that it's accumulating bit by bit by bit, the tax? Well, okay, continual positive slope. Yeah, Jimin.
As the taxable income is like growing bit by bit, the tax due is also growing.
Did you hear that? She said as the taxable income grows bit by bit, like maybe $1 at a time or 50 cents at a time or 25 cents at a time, every time your taxable income grows a little bit, what does your tax do? Increases a little bit. This is a powerful idea, really important. So, like from that point right there, we can say the taxable income increases a little bit. How can we represent that? What is increasing the taxable income a little bit? Say if taxable income were X. Time? I know those guys know. How about LJ? How can we represent increasing taxable income a little bit, like with symbols? If taxable income is X. Roman.
You could represent it as
Delta x. Is that what you guys were thinking? Raising your hands? Yep. Delta x. So now we're thinking of a delta x being a very small increase in taxable income. And when we have that small increase in taxable income, associated with it is? Which is? What does delta y mean? Oh, that's not good. Anyway, this should be from here to here. Okay, so for that little increase in taxable income, there's an associated little increase in tax due. And so then at the end of the year, let's look at this. Okay, so at the end of the year, we can think about, okay, so I made $49,500 this year, and therefore my total tax due was, whatever, $8,500. But how can we think about it has been having accumulated? So rather than a static idea of, I'm just going to look at the tax table for this amount of total income, and it's going to crank out my tax due, I'll write the one check and send it in. Is that the idea of accumulation? That's not the idea of accumulation. So how can we think about that amount as having been accumulated? Right, so we can think about it like a 50 cents at a time or a dollar at a time in taxable income. Each time we increase that taxable income a little bit, we're going to increase the tax due a little bit, and so we just keep adding those delta y's. Delta y plus delta y plus delta y plus delta y. Keep adding them all year long, and then at the end, by the end of the year, we've accumulated that amount of tax. Really important idea. This is like the underlying idea of integration, okay? Which we're going to get to soon. So this is the idea of integration, that things accumulate in little bits. You don't suddenly have to pay this much tax. It grew little bit by bit over the year. Okay, so what I want to do is don't peek at any notes or any printouts that you may have made. Let's practice and see if we can rewrite these two functions. So, can you recreate, first of all, the marginal tax rate function? So we'll call it R. This is practice to see if we are getting what's going on so far. So, can we rewrite this marginal tax rate function? And then, can we recreate the tax function without looking at notes or printouts or anything? All the information is there to do it. And if you've been absorbing what we've been talking about over the last week, and you understand what's going on, we should be able to recreate this. Recreate these two functions. So see how you do. You can work together, but for this one, I want you to recreate this rate of change function, and then over here, try to recreate the tax function, but do the left one first. And I think our values here were 83.75, is that right? And what was the other one? 34? This is practice, it's a warm-up. See if you can do it. Don't peek. See if you can write down, represent symbolically these two functions now, given the graph. Okay, the graph too good. Yeah. Good. Okay, last one. Take it late, be on time.
Oh, okay.
Yeah. Last time, gotta be on time. Good, last time. Okay, I can help. Wait. What kind of functions are those? You and yours. As you multiply by x, that will grow. Oh, is that what that's happening there? No. No. Okay, right. Right. Okay, good. So do this one first. Is the rate? Is the rate function? Or is it the times 2 function? That's the rate do the rate function first. Do the rate function first, the one on the left. And then do the tax function.
It's just like writing
So the first was just the rate function.
It was just the value.
Holding that with 0.1 horizontal line.
Because then the conditionals will describe where.
For all of my yeah. Okay.
So basically, like,
Redhead? No, sounds just too great. Given a taxable, it's just going to keep the rates. Oh, okay. So this is just beside each other.
Right. The first side.
The income increases, but what does the rate do? You say the rate increases. You're saying the rate is going up.
Okay, so then. I did. Probably more 34,000.
Yeah, use it, make it recursive.
Let's do it.
Yeah.
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 Is that plus? Is that plus? Yeah. Okay, yeah, yeah. Good job. Yes.
No, you had it right on the.
Okay, so there was a few of you that were doing this for the rate function. Let's talk about why. So you recognize this first rate was 0.1, and so this was a common thing from what, 0 to. What does that imply about the rate as x increases across that first interval? So what's going to happen to the rate as x goes from 0 to 83.75? This will increase the rate, but what is the rate really doing? Staying constant. Staying constant. So no matter what x value we have in that, we want the rate to be what? Just 10%. You see? It's a constant function returns the same constant value no matter what your x value is. Okay, I'll give you just 1 or 2 more minutes if you haven't finished yet. If you want me to check, I can check. Good, all right. We'll do the third one. Just up to, what is that? Sorry. 60,000? Okay, just go ahead and do it up to 60,000. Yeah, so do the 3 parts. Okay, last chance. Anyone have a question or want me to check? Okay, so
Because if you made like $10, you'd have better money.
Yeah,
It'd be like, if it's like this, it's this accumulation tax rate. Yeah, that's good assets are
I like this paper solution rather than just the feel. I don't like looking at it again, and I was like, bro. I'm gonna just 3 hands like I gave it a good honest like legit.
No idea if it works.
I'm gonna take the way out.
Okay, so, any questions? Is that what you did? Does that make sense? Okay, so let's ask a question here. What does x, just this quantity here, x minus 34,000, what number is that exactly? What does that mean? Richard?
It's the change in the amount of income that you made over 34,000.
Okay, so he said it's the additional amount of income you've made over 34,000. Do you agree with that? So if your total income was 50,000 for the year, that value would be what? 16,000, which would be the amount of money you made after the first 34,000 that you made. How can you talk about that number in terms of a tax rate? So it's still a amount of income, right? So how can you qualify it as in terms of a tax rate instead? Connor.
That's like the third tax bracket. So that's the amount of money that is taxed with the 25% rate.
Yeah, did you hear that? So this is the amount of money of all your income, every taxable income, that would be taxed at 25%. So you could say it either way, but either way, it's still what? An amount of money. It's still an amount of taxable income. Whether you qualify it as the money you make after 34,000 or you qualify it as the amount of money that's taxed at this rate, 0.25. Okay? What does this mean? Somebody new? So the second one, 0.15 times x minus 8375. I want to give this a try. Joe.
That's the amount of tax you owe for the bracket of 0.15.
So he says the amount of tax you owe that was taxed at 15%. Yeah. The amount of tax that you owe that came from your income that was taxed at 15%. Agree with that? What's another way to say it? So it doesn't change what the value is, it just changes the reference that you make. So somebody new.
It would be delta y.
Okay, it would be delta y. So, but in terms of all the tax stuff, yeah, you're right, it would be. Can you say it? What's that? Calvin.
The tax due at that point.
The tax due?
The change in tax due.
Relative to
the that rate and between those two periods.
Okay. Yeah, so this is the amount of tax that you owe. So I think the first time we said in the 15% bracket, right? So what's another way to say it? The amount of tax that you owe. Or which, yeah, Dalton.
Between income of 8,375 and
Yeah, for the income that you earned after the first 8,375. So it's the total tax due on the income that you earned after the 8,375. Or the total income that you earned at the the total tax due at the 15% rate. Either way. Okay. Any questions on that? So let's look at a new situation. We've kind of looked at all sides of the taxes. So how about something new here? Okay, so here's similar but different. So what we got here is, over here I'm showing this red circle there, the ball, that's a basketball. Okay? It's rocket powered. Okay? It's a rocket powered basketball. So now I want you to, so this is the height, showing you the height of the ball from the ground. This over here is showing you a feet per second situation. The y-axis represents feet per second, and then number of seconds. So what I want you to do, just for a minute or two, just make sense of this. So in the context, talking about the basketball, what's happening to the basketball, make sense of what these graphs are showing you. Okay, so talk to the person next to you. Make sense of what this is showing you.
what does it make?
Don't read this yet. Don't, just keep talking.
So that's
Yeah, the feet per second is massive.
yeah, I think that those coordinates on the graph are
I think 1.5
Okay, so don't read yet, just hold that off to the side for a second. So let's just make sense of what we're seeing here. So what is being shown here? Somebody new. What's your name with the necklace? Nicole. What did you guys make sense of for this? Maybe start over here. What is this left graph telling you?
That for the number of seconds.
Okay. Okay, so this is talking about how high the ball is going in feet. Agree with that? Some are nodding. Is it Charles?
Yeah.
Do you agree with that? That this is how high the ball is going? You say no, so what do you think?
For every, I guess, half a second, you could say that it's traveling, the speed is an additional foot per second.
Every half a second, the speed is an additional foot per second. So you're saying this graph is showing increase in what?
Increasing velocity.
Increasing speed or velocity. So is it showing increasing height or speed? Okay, it's showing increasing speed. How is the speed increasing? How is the speed increasing? Be very specific. Saskia.
How's the speed increasing?
Yeah, so what does this tell us about how the speed is increasing?
I mean, it's telling you like how fast it's going. Like.
And in what way? In what way is the speed increasing according to that graph?
Gradually, like it's building up. Like it's going like to a certain point, and then it's like it has to jump up.
Okay. So every moment the speed is increasing a little bit more than before. Every moment. Every moment the speed is increasing a little bit more than before. Agree with that? Jimin. Let's talk about time. So let's just, in terms of time, as time goes by, how about instead? So as time goes by, what happens to the speed?
The longer it's been going, the faster.
Okay, but specifically, how does it increase in speed? Ben?
Every 1 second, the speed of the basketball increases by 1 foot per second.
Okay.
And it jumps. It's not bit by bit. It's an interval. It's jumping up every 1 second.
So in the in this second half of the first second, what is the speed like there, Nathan?
Was it like the rockets, like getting faster every second?
Okay.
It's not like gradually getting faster every second.
So if it's not gradually getting faster, what is the speed in that second half of the first second?
1 foot per second.
Yeah, and so what do we call that? Well, constant speed. So in each half second, the ball is traveling at a constant speed, but then in the next half second, what? Savannah?
Traveling at a faster constant speed?
Yeah, faster constant speed every half second, right? Faster constant speed every half second. So what in the first half of this second right here, from 1 to 2, what's the constant speed? 2 feet per second. So for that whole period of time, it's traveling at 2 feet per second. But then, in the second half of that second, it jumps to 3 feet per second. So the speed is increasing, but it's increasing in steps, so that over every half second, it's staying constant, but then it jumps to a higher speed. So before you think that that's too far-fetched, this is actually very similar to German bombs in World War II were called buzz bombs, okay? And they were rocket-powered, and so every time a rocket fired, it would jump the speed up to the next higher speed, and then another rocket would fire, and it would speed the bomb up. And so the speed profile of those bombs were much like this. Every time a rocket fired, it boosted it to a faster speed until the next rocket was fired. Okay? So let's, can you now, oh, you got your handouts now, so now let's do the handout. Can you write the rate of change function first, and then can you write the height function? Can you write the rate of change function, the first one there, and then can you write the height function? See if you can do it. Do what you know how to do.
seconds. I know. I did read this. Okay, so now there's no y. Oh wait, no, x. We're in the x. Second. So then, if there's no x, it's only increasing y.
Yeah, I mean, oh.
Okay, use a recursive formula for this.
I just did.
Oh.
It's just 0, 1, 2, 3, 4.
Huh? Oh, rate function. So we want to recreate that rate function symbolically.
Just trying to think about piecewise function.
Do you need a piecewise function for that?
Well, not really. I don't think so. Do you? I mean,
We're forced to chop that into pieces to define it?
no. Well, oh, that's a little confusing to me. Just like the thing about it.
Absolutely. There's no way you can write this without chopping it into pieces because of these abrupt changes. You have constant rates and then abrupt changes. Gotta have a piecewise.
Okay.
When t is in that bracket, that's what that's the two.
I mean, that's just what
The rate equals this when or if t is in this. It's not equal to every time. So it's like that's like if and we're got the calculator.
The recursive formula, is this the slope formula?
So it's like what we've been doing. So if you want to grab the rate function and now you want to build the quantity function.
So we just assume it's I mean, it's just in that part. Yeah. X will just be time. So
Okay.
I mean, it was.
So how'd you do on the tax? Tax function. So we had the rate of change of tax, and then we built the tax function, right?
Yeah, so the plus.
Where did that tax function come from?
So it's pretty much the same.
It came from the rate of change associated
I mean, that's
with
right.
the
But then it accumulated, right? And we had to like add on what we had from before every time it changed.
So I take the change that's right here, right, and like this,
Okay.
the second or whatever.
Okay, so
But see, that I just don't, what is this here? This is height. Is this
Yeah, so-
seconds?
Yeah, we're not actually graphing it. I'm just showing you the height of the basketball. Eventually, we're going to show it graphed against time, but we're not doing that here. Just showing you the height.
Okay.
But what you are setting up the function as if time was increasing
But I
too.
want to.
Yeah.
Okay.
That's what you want to do.
Okay.
Okay, better.
So,
Yeah.
Same.
Feel better now?
Yeah.
Same thing
Yeah.
as the first.
Did I use capital H or small h? What did I use? Did I? Capital H, okay.
Oh.
Yeah.
Okay, so in general, how is the height? If the rate of change of height is constant, then how will we model how the height changes? What in general is our model to model how the height changes if the rate of change is constant? This is what we've been working on. Meaning, what definition will we use to model how the height will change if the rate of change is constant? What is it? Did you say m? M times? Remember this? We spent almost a week doing these piecewise linear functions. If the rate is constant, then the quantity will increase linearly, right? At that constant rate n. What is AB? What does AB represent? X naught, Y naught is another way to say it. What is that? Starting point, right? Starting point. And our starting point for B is always in the recursive formula is going to come from exactly the height accumulated over the entire interval of the previous function. Okay, so we're going to have the rate in the first half second, 0 times x minus 0 plus how much height is accumulated before time equals in the in this first before we started, say here. 0 height is accumulated at 0 seconds. Okay, and so that's from 0 less than or equal to x less than equal to 1/2, right? So now, what's the rate in the second half second? 1. You can just look at your rate function. So we're going to go x minus, so now we're starting here. What's that? 1/2. Starting here, and now we're building the height accumulation for this little part, right? For 1/2 to 1. So we need to add on the height accumulated in the first half second. Third interval is from 1 to what? 1.5. What's the rate of change? 2. And so we want the amount of time since when? In this interval, we're looking at the amount of time since when? Since 1. But we have to add on the accumulated height since when? From all the accumulated height up to that point 1. So this should feel just like the tax function. It should feel just like the tax, and it should feel just like all the stuff we did with making the piecewise linear function. Okay, bring that to recitation. So in recitation, you're going to go over homework questions from like a week ago. That's the first linear homework you had last weekend. You can spend a little more time building this height function, and then you'll have your quiz. Okay? And I'll post homework this afternoon. Have a good weekend. Yeah.
Alright, I'm sorry. I know you sent out that email about this, but I know I was with him.
Don't say anything because I'm still recording.
Sorry.
So let me. What am I trying to do here? Let me turn off the recording.